Right, hello. This is just intended to be a few notes on this particular A-level maths exam. The International A-level maths, paper 3, code WMA 13/01. So at the same time, hopefully it will be useful to A-level students in general. And if you're not sure, or if you've never heard of A-levels before, they are the exam that people normally take about 18 when they're 18, and it also functions as a university entry exam, so that gives you a bit of a clue of the level. And down there you've got www.maca.co.uk. If you go to that site, you can get full model answers for this particular exam paper, plus possibly the exam paper itself, although the exam papers themselves are subject to copyright. So, as I say, it's just a couple of odd comments rather than a comprehensive overview of this entire exam paper. So if you can have a look at that. I know you can freeze this, so I don't need to hold that on too long. You can freeze that if you want to have a look at it in detail. I think the one thing I'd say about these inverse functions, what it confuses a lot of people, is that this idea of switching between the values of x and y. But really, the thing to notice is that these values of x and y, they don't actually mean anything. You know, these two functions up here, they are exactly the same function. Whether the fact that one is an x and one is an y is not relevant. You'll stick some value into there, and you'll still get the same value out. And likewise, when you get an inverse function, you know, these two are the same as well. The only reason why you reverse the variables, you know, you convert the x's into y's and vice versa, is so that you can map the function and the inverse function on the same graph. You know, with x being the horizontal axis and y being the vertical. I mean, you'd have a situation like this. If you map them on the same graph, they are symmetric about the 45-degree angle line, this dotted line. So I mean, you can imagine that, say for example I put I don't know, say that's 3, and I map that well, I'll go on to this function here, and say that maps onto, say, 5 or something. Then the thing is, if I take that 5 and map it onto the inverse function, what should come out is 3. So that's basically fulfills the idea of this side, you know, the function and the inverse function. I put 3 into the function itself and I get out 5. I then put 5 into the inverse function and I get out 3. So I get out the original value. The fact that I've put in the original value I put in was an x, and the value I got out was a y, is neither here nor there. You know, I mean, that's not relevant. It's just, you know, what I put in eventually is the same number that I got out, and that's all you need to worry about. The x and y's, you know, that's just you know, as I said before, really, they're not directly important. Now this number 3. Right, I'm sorry about that. Right, sorry about that. Right, this integration, this involves a log in your answer. I mean, that's not surprising. The first thing whenever you have a rational function like this, the first thing you do is to look to see whether the top is the derivative of the bottom, which in this case it's not directly, but you can fiddle around with the integral and get that situation so that fact we've got 9x over 3x squared plus k. Okay, so the top is not the derivative of the bottom, but if I play around with this and I convert that to be 6x over 3x squared plus k, I then fiddle around with the and multiply it by 3 over 2 or 1 over 5, and that becomes equal to that. And that now is the desired situation. Now, because the top is just the derivative of the bottom, it just becomes 3 over 2 log 3x squared plus k. So that's whenever you've got a rational function, that's the first thing you look for, to see whether the top is the derivative of the bottom. And even if it's not, then the next stage you do is try and see if you can sort of decompose it into different, you can have this just one single term. You may be able to decompose it by maybe using long division or whatever, in order to decompose it into two or three separate terms or whatever, each of which is integrable. I say this because that would help if you could adopt that attitude rather than sort of going straight in and using substitution or integration by parts, which a lot of people do. So having produced a log, the next thing it says is find the value of k. So essentially you've got I should have said that you're actually introducing 5 over 2. You've got limits of 5 and 2 there. So what you're going to have is 3 over 2 log 75 plus k plus log 12 plus k equals log 8. Sorry, I'll go back to the question again. So is adjusting that integral here to log 8. So again, that's basically what you do get eventually. Now it would be correct to say, okay, 3 over 2, that's log of 75 plus k over 12 plus k equals log 8. Sorry, that should be minus, shouldn't it? That's minus. Right. So one thing you definitely cannot do here is anti-log that straight away, because you need to be sorry about this. I'll make that log. I'll make that a log. Oh, sorry, I'm getting mixed up here as well. Sorry about this. Right, I cannot anti-log that straight away because you need to have a log on the left-hand side equals a log on the right-hand side. But you've got a 3 over 2 here. It's not a straightforward log. That's a 3 over 2. So what a lot of people would then do would stick it up to be on top here. So you'd have log 75 plus k over 12 plus k 3 over 2 equals log 8. Which is correct, and you could anti-log that now because you've got logs on both sides, but you're going to have hassle with the arithmetic, with this index basically. So what would be much better, instead of doing that, would be to have log 75 plus k equals 2 over 3 log 8, and that equals log 8 over 2 over 3. Now you got a log on both sides, and you can just straightforward anti-log it, so it'll become And what is 8 to the power 2 over 3? Well, that's equal to 4. You can either take the cube root of 8, which will give you 2, and then square it, that'll give you 4. Or you could square 8, which will give you 64, and the cube root of that is 4. Now, question 4. This is possibly quite a boring question in a way. But it's asking you to, it's giving you an equation, n equals a b to the power t, and it's also showing you a line on a linear line on a graph, and it's asking you to find out the equation of this graph here. And this caused a lot of problems for a lot of people, you know. But it's a straightforward linear graph, so you know, the function on the vertical axis is log to the power 10n x. So it's good idea to start off with that. Log to the power 10n equals, you know, you don't have y equals such and such. So log 10n equals that. You know the can you see it on here? You can see where it intersects the graph. So that's plus 308. That's the y intersect in parenthesis. Now you just need the graph of now you just need the gradient. It's t on the horizontal axis, so you need to stick in the gradient there. So you need to work that out from just these two values here. It's 3.85 minus 3.08 all over 5, which I don't think I've got handy. Have you got handy the figure? Yeah, I haven't got the actual figure handy, but you know, that's the basic idea anyway. So it then asks you to find out. Goes back to the original equation that you're given, a b over t, and it asks you to work out what a and b are. So the procedure then is just to say, okay, take logs of both sides. That's log a bt. Again, you don't get caught in, you don't take the t down here, because that t is just on the b, it's not on the whole thing. So that's one error some people fell into. So it's actually log a plus log b to the power t, and then it's log n equals log a plus t log b. So you can see what you can do there. You can log the log a logs onto the 3.08. This t log b logs into this value here, and hence you can find out what a and b are. Now this is a particularly interesting one. Caused it quite a bit of trouble. One of the first things, you could look at these types of graphs in general. If I had sort of y equals, I'll put y equals x. And that would be that. If I had y equals magnitude of x minus 2, that would be the graph shifted down by 2 units in a vertical direction. If I had y equals x minus 3, for example, that would be the graph shifted to the right by, or translated to the right by 3 units. So the equation we're given here is y equals if I can just make just one adjustment to that, and that would be kx minus 9 over k. The thing is, just by looking at that, I now know what this, well, I know I can now extract a couple of figures from the original graph on the question paper. This one here. I know that it's this type of shape here, the V-type shape, but it's been shifted down by 2 units along the vertical axis. It's also been translated by 9 over k units to the right. So I know that the x value of b is 9 over k. I mean, that's what it asks you to calculate in AI. Find in terms of k the x coordinates. Well, just by looking at the form of the equation, you know that it's 9 over k. Most people probably did it another way, but what I'm saying is just by looking at the equation, you know the answer anyway. It says find the y coordinate of A, i.e. the y-intercept. Well, you know, that's setting 0 into there. That'll give you the magnitude of minus 9, which is 9, minus 2, so that's 7. So you know that that's 7, and we know that that's minus 2. And you also know that that's 9 over k. Straight off. Part B, can you see on there? Part B. Part B asks you to find the range of values. Right, yeah, what so you got kx minus 9 minus 2 equals 0. Find the range of values that satisfy the inequality. Yeah, I mean, there is an elegant mathematical way of handling these magnitude questions, which, although it's mathematically elegant, it's probably not the best way to do it. For example, if I shifted that round and said, okay, x minus 9 is less than 2. If I was to square, you know, if I had an equation or something like that, an inequality like this, actually, come to think, is it going to work in inequality? Actually, I'm going probably into a bit of a dead end here, but just to, while I'm on the topic, if you had an actual equation like that, what you could do is you could square both sides and then just proceed as a straightforward equation. You know, that deals with the magnitude, this magnitude problem straight away. But the fact of life, although that's the mathematically elegant way of doing it, in practice it's not the most practical way of doing it. What you really need to do is just look at the two situations. You look at the situation where kx minus 9 minus 2 equals 0, and then you look at the other situation where minus kx plus 9 minus 2 equals 0. And that's really what you do in any situation where you've got inequalities. You split it down into the two situations like that. You know, it's not the most elegant way of doing it, but it's the most practical way of doing it. That's the one that's going to get you the answers in the most direct way. Now, this last bit has caused a lot of problems. It says, given that the line y equals 3 minus 2x intersects the graph at two distinct points, find the range of possible values of k. Now, this is the graph I've got. Now, the line I need to stick in is y equals 3 minus 2x. So that's going to be, just have a look again. Minus 2x, yeah. So it's going to be something like that. If I send it through the point there, that's going to be 3, and the gradient is minus 2 of this line here. So that line is fixed. This line here is going to vary as you find the values of k. And what the question is asking you is to find the range of values of k such that this line will cross this line in two separate places. Now what I've done is I've stuck it through the point so that it's actually crossing this line here at one point at the moment. But the reason I'm going to do that is I can then find out the critical value. I find out the critical value of k when it just crosses the line at one point. So the actual value of k is either going to be one side. It's either going to be k greater than the critical value or k less than the critical value. Because I should say what's going to go back to the original question. K is really it has two values here. It's the gradient. It's the gradient of that and that. The magnitude of k is going to be the one of these is going to be plus k and one is going to be minus k, or vice versa. That's the gradient. Now also you got k enters into this term as well, and that's the term that's going to tell you how much is going to be shift or translate along the horizontal axis. So what we actually want is we want this line here to sort of concertina to the left, because this value here of 7 and this value of 2 is going to remain constant. So I use this term concertina, because it shows it sort of graphically well. It's either going to shift this way, keeping the values of 7 and 2 equal, or it's going to be shift the other way. But I actually wanted to shift the value of k such that it shifts this way, so that this red line will then cut it in two separate places. And that is consistent with either the value of k increasing or this value 9 over k decreasing as k increases. So essentially what I'm going to have to look for the critical value here, and therefore k will be greater than the critical value. So to work out what k is, I don't really need, I've got the equation of the line, which I have to remind myself again. It's y equals 3 minus 2x. Y equals 3 minus 2x. Well, I know straight away. I know y is minus 2. Can you remember? 2 minus 2 is the 3 minus 2. And that, well, I've got the diagram up at the top here, haven't I? It's 9 over k. And that'll give me the value of k straight off. And if you've followed what I said before, once you find that value of k, then the actual value of k I want is k greater than that value. I don't think I need to say too much about this particular one. It's a straightforward dy by dx situation. Find the derivative of this using the product rule. That'll give you this. It's all you need to find out is k here. It's giving you the form of the answer already. Hence, find the values for which f of x equals 0 here and here. To do that, you don't need to, you set the whole thing equals to 0, but in fact all you need is to work out is the top. You work out 5x squared plus 9x minus 2 equals 0, because whatever's on the bottom, that doesn't alter the when you set f of x, when you set the derivative equal to 0, then what's on the bottom doesn't have any effect at all. That can be anything. That's not going to. The only thing that's going to make it 0 is if the top is 0. Now, it's got a little bit of thing at the end here, which caught a lot of students out. It says that the function, this is the one up at the top here is f of x. Now we've got a new function here defined by g of x equals 2f of x plus 4. Find the range of g. Well, I mean the range of f, I'll have to look at my values here. This I think was 10. So that the y value of p was 10, and obviously we don't actually. Oh, actually, I should have stated also that this is in the range of -9/4 and 0, and that I think was 2. So that the actual domain is somewhere out here. So it includes p. Now. So basically what we're doing is we're just, as regards the f under consideration, we're just looking at the f to the left hand side of the vertical axis. So we don't actually know what f of 0 is, but we can just stick it into here. Stick a 0 into here, that will give you -30. So the range of f is 10 to -30. You know, the range just refers to the values on the vertical axis. So when we need to so the range was 30. The range of f is that. So g, the range of g, well, you take the bottom value of 30. I mean, all that's going to happen here is that the f values are just going to be doubled, and it's going to be then shifted up the y-axis by 4. So there's nothing strange here. We just need to look at the extreme values. So 30, that becomes under here becomes 2 times that, which is -60. Subtract 4, so that'll be -56, and that'll be the bottom value for g, bottom value of the range, g, and 10. Well, the range of g will be 2 times that, which is 10, plus 4, which is 24. So that's the range of g, between -56 and 24. This is might put well, again, it did cause problems for a lot of people. This, but it's a lot easier than you might think. When I say easier, you've got a cotangent here, and to convert a cotangent to a cosecant is actually fairly straightforward. Well, using a straightforward identity. When I say straightforward, it derives from the very basic identity of that. If I divide that through by cosine, that becomes tan squared that plus 1 equals secant squared. Okay, so that's possibly you might be able to identify that. That's just derived from this very, very basic one at the top. Likewise, if I divide through by sine, sorry, I'm dividing through by cosine squared here, aren't I? So I'm dividing through by sine squared here, and that'll give me that. So that's the that's right, isn't it? Sine. Yeah. So that's the one I want. That's what I mean by it's very easy. It's you don't have to actually remember it per se. You just derive it from this very, very easy identity here. So that'll get rid of the cotangent for you into a cosecant. Now the only little other bit there is you've got a sine and a cosecant on the left hand side. Now if you can imagine that okay, you keep the bracket, you've sorted the bracket out. Now on the right hand side you have a 13 sec theta, and if I divide through by the 2 sine theta. So that on the right hand side now I've got 2 sine theta. So that equals 13 over 2. That's 2 sine theta, and that's actually a cos theta. So that equals 13 over 2, 1 over, basic identity is again sine 2 theta. And sine 2 theta equals, oops, sorry, sine 2 theta equals cosec 2 theta. So that's what you're after. So yeah, that's basically it. Well, that's all you need anyway. Now, the second bit asks you to you solve that. So really, you're solving that. So it's a straightforward quadratic equation, and you end up, for example, cosine 2 theta equals 5. Again, this might seem fairly basic to a lot of people, but this is where people did slip up on this. I mean, first off, it's cosec 2 theta, isn't it? Now, how do you go from here? Well, what you just do is you just say sine 2 theta equals 1 over 5. I mean, you just flip it over. You've got 1 over sine 2 theta here equals 5, so just flip it over. And when you go from here, you then say 2 theta equals if my memory says you're right, 0. So here's the 2. Right, sorry about that. I'd lost my figures somewhere. Yeah. So 2 theta then equals these two values, and then you just need to say theta equals that. I mean, there's all kinds of problems on this. Some people sort of just, instead of writing that down 2 theta, they put down theta and just lose it that way. But it's a general problem that some people don't realise that for a sine or cosine or tangent, then there are 2 answers within a range of 0 and 2 pi or 0 and 360, whatever you want. So a lot of people would miss that out and then, okay, do this and just get one answer. Other people would say, okay, they'd work that out and then they'd start working out the second answer after they work out the first answer. Well, to me, it just creates a bit of a mess. You just do it logically, line by line. You get the 2 answers here, and those are the only 2 answers that will eventually fit into the final answer, because fit within the final range required. So I don't bother to put any other answers down, and because I know beforehand that I'm just going to divide them both all by 2, and then yeah, just on the same line, just put the all the answers, and that's straightforward. It's just rather than the total mess that some people manage to make questions like these. Alright, this is another seemingly fairly straightforward calculus. You need to find out the maximum of this graph, or maximum of this equation here. Now, the figure's a bit more nasty and so on. And what caused a lot of people problems was you ended up with an expression like this: t minus 10 equals 9 e. So some people would come along and anti-log that. Well, you can't anti-log that. I mean, I've just talked about in an earlier question that you need to have a log equals a log before you can anti-log something. Sorry, this is the opposite direction. Here you think in terms of taking a log, but you can't take a log of this because it's not an e equals an e whatever. You've got this constant here. So if, for example, if you say, okay, I'll take the logs of both sides and say, oh, equals 9. You know, that's just wrong. But that's what a lot of people did. That's just wrong. You know, if that 9 wasn't there, you could think in terms of, okay, you know, just doing that. But that 9 knackers things up. You can't do that. You can take a log of both sides, so you could say, oh, 10, you know, equals log 9e. That's what you do. And then you say 2 times 10 equals log 9. This is obviously natural log. I should put in plus log e 75t. So you've got t minus 10 equals log e9 plus, and you proceed from there. That's and one extra little thing on here is that it does say find the sprinter's maximum value. So what a lot of people did, which is quite a general problem in questions like this, is they work out the t and then they just leave it at that. But that is not the answer, is it? It says find the sprinter's maximum value. So you need to take the t you found, stick it into the original equation to work out what v is. And again, I need to stress this because this is a very, very common problem. You have a very basic problem, y equals 2x squared plus 3 plus 9 or something, and people are asked to find the maximum value of that. People will, you know, do the correct procedure, differentiate, set the dy by dx equal to 0, find out what x is, and then they will leave it at that. But x is not the maximum or minimum. The maximum or minimum is the y value. So that's what you need to find out. Be aware of that. So this is the last question, which again is a straightforward. Is that okay? Show the x coordinates of m is that. Well, yeah, that's differentiation again. This time it'll be the product rule, and setting dy by x equals to 0 will give you this. Now, it then actually essentially asks you to solve this equation. Now, first thing to state is that in general, not in general, there is a specific special case of this. If that was 0, that would become a very, very easy situation. You would just divide through by cosine, and then you get 2 tan x plus 1 equals 0. And you could just solve that to find out what tan x is, and you know, Bob's your uncle, no problem. But the fact of that's just a special case when the right hand side is 0. Otherwise, you can't use that. I need to stress that because it was fairly obvious from what students were doing, but some were trying to use that method. They're trying to get a tangent out of this situation, which is not possible. Not possible because the right hand side is not equal to 0. Now, the way I'm going to personally recommend you do this is to start out by saying 2 equals cos x equals r cosine x minus, right. So that's the way I personally am going to recommend you do a question like this, whereas actually most people did not actually do it this way. I think a majority of people played around with the left-hand side using things like, cosine squared x equals, cosine x equals the square root of 1 minus sine squared x, and fiddled around with something like that, or they used a similar situation for tans and secant squares and things like that. Play around with the algebra, and obviously at the end of the day they would get the right answer, but to my mind it's a bit messy and not the most elegant way of doing it. Even the people who did this method did not, I think probably the most of them didn't actually do this straightforward method. Did not actually do the method I'm recommending here. They would put r sine x minus alpha. Now the reason I'm putting cosine is because if you've got a choice of, if you've got an equation in sines and cosines, and you've got a choice, you've got an equation in sines and cosines, and you want to put them in an equation in just either purely in sines or purely in terms of cosines, then you always go for cosines. And the reason for that is because of the symmetry of the situation. If you've got a sort of cosine x, the answer to that would be the cosine. Oh, sorry, I'm getting mixed up here. Cosine theta. There would be a symmetry insofar as the principal value would be given by this, but also, say if it was 30, it'd be plus 30, but it would also be minus 30. So there'd be this symmetry around that particular axis. You go around again, say 360, and it'd be 360 plus 30, 360 minus 30. So essentially you'd have x equals n 360 plus or minus the principal value that you've got from your calculator. Sorry, I've reverted to degrees here, but this question we're doing here requires radians. But you can see what I'm saying. Using cosines, you end up with a very, very, very nice compact formula. So to my mind, that's what you would always go for. And you can recognise what I've put a minus sign here is that when I expand it out, it'll be cosine x cosine like that. So there's no problems with pluses and minuses being different on either side. So I can just do a straightforward comparison here. That's sine x. So I'll compare it with this term here. So that the coefficient is 2. And the coefficient of sine x here is r sine alpha. The coefficient of cosine x there is 1. The coefficient of x, sorry, did I say cosine x? Coefficient of cosine x there is 1. The coefficient of cosine x here is r cosine that. And then I square both sides. If I square r squared sine squared plus cos squared equals plus 1 squared. Okay, I've squared both of them and added. So that just becomes r squared equals 5, implies r equals root 5. Again, I'm scooting through these because most of you probably know. Once I reach this stage, most of you probably know what I'm doing anyway. And then I divide one by the other. I'll divide the top one by the bottom one, and that just becomes tan alpha equals 2. And tan equal to 2, to my mind, is 1.107, I think. That's the principal value. In general, I might need to check the other value, but the way I've laid it out, the answer is only going to be the value in the first quadrant, so that's okay. That's the principal value, and that is also the one to use. And then on, you just adopt the form I've been recommended. the 2x plus that becomes cosine x minus 1.107. 107, yep. So that left hand side now has become that, and that equals minus 2. So cosine x minus 1.107 equals minus 2 over 5. And now x minus 1.107 equals again, I've lost my values here. Don't quote me on this, but I think that's the value there. Yeah. So in general, I would then have a list of different values here, because as I said before, a cosine would correspond to two values between 0 and 2 pi, and also you got this factor here, so you might want to consider values beyond 2 pi, but that's not applicable here, because I know from the formula, from the graph, that I'm just looking for 1. So that I don't need to bother about that. I just need to stick that one value down, and there you are. You just progress from there to find out what x is, and that's it. So that was the last question. So thank you very much if you've managed to. Thank you very much if you're still with me at this particular point. Hopefully that's been useful. But as I say, I gave you the web page at the beginning, www.maca.co.uk. That'll go on to the where you can get the full model answers for this particular exam paper, and also the exam paper itself. Well, it'll give links to the exam paper where you can get the exam paper itself. Sometimes they're under copyright, these exam papers, if they're quite recent, but otherwise they should be available. And if you want to look on my YouTube channel, there are hopefully some videos on there which are also useful to you as well. So thanks again for bearing with me, and cheers for now.